Okay, class, welcome to today's lesson on subtracting polynomials. It's very similar to yesterday's lesson of adding polynomials, except now we're taking them away. So, a couple things to keep in mind. Two key points right here. Number one, each term, each one must be subtracted for the second polynomial. So we're going to be taking away each term of the second polynomial. Now with algebra tiles, one can physically remove each piece. Or when we're doing the drawings, you show that you're removing the piece by subtracting it or crossing it off. So easier with tiles, but we'll still work with the drawings and get this done. What we're going to do now is we're going to draw the very first polynomial. So we have a 3x squared. So there's 1x squared, there's 2x squared, there's 3x squared. Then we're going to draw a negative 4x. Now again, you can orientate these x tiles vertically or horizontally. I just randomly chose to go horizontally. So there's my 4x tiles. And then I'm going to have a plus 5. 1, 2, 3, 4, 5. And you can arrange them however you want, any way that you would like or prefer. So then what I'm going to do is I'm going to take away a positive 2x squareds. Well, here is 2 positive x squareds. Remember, this is a plus sign. For the 2, it's positives. So I will take away 2 positives. Then I will take away a negative x. I see a negative x, so I can take it away. And then I will take away a plus 3. So I'll take away 1, 2, 3. Again, each term of this second polynomial was removed, including the proper signs. Okay, and so what's left over then? Well, I have an x squared term, only one. I have 3 x's and they're negative, so negative 3x. And I have 2 1 tiles and they're positives, so I will have a positive 2. So that is my answer, x squared minus 3x plus 2. Now it's simple when we have all the pieces. We had positive x squareds, we had negative x's, and we had positive 1 tiles. So it's simple. The question where it gets hard, though, is what if we don't have these pieces to physically remove? That's the problem. So let's draw this first polynomial and have a look. We have 4x squared plus 5x. So here is 1, 2, 3, 4. There's 4x squareds. And then we'll have 5x's. 1, 2, 3, 4, 5. There's 5x's. And then I'm going to draw my 5 1 tiles. There's 1, 2, 3, 4, 5. So there's my 5 1 tiles. Okay. So what I'm going to do now is I'm going to take away an x squared. So I'm going to take away not just 1, but 2. Keeping in mind that is a positive 2x squared. So I can take away 1, 2, because there's 2 present. Then I'm going to take away a negative 2x. But I got a problem. There is no negative x's. So there's no negative x's. What can I do? Well, I have to add a 0 pair first. So we must add a 0 pair, because that doesn't change the value. So if I add a 0 pair of x's, I don't change the value, because if I have, how many x's? 5x. Sorry, I start with a 5x, and I'm just adding 0. I still have overall 5x. Okay, so I don't change the value. But what it does is it allows me to take away a single negative x. Now the problem is I have 2 of them. So how do I take away negative 2? Is I got to add another 0 pair. And so there's another 0 pair, and so I can take away a second negative x. So the 0 pairs allow me to take away 2 negative x's which weren't originally present. Okay. So same thing with the 1 tiles now. I need to take away -3 1 tiles. And I don't have any, so I'm going to have to add some 0 pairs. So there's a 0 pair. I don't change the value. I still overall have a +5 value. And then I'll add another 0 pair, and I'll still have overall a +5 value. And then I'll add one more 0 pair. I need to add 3 because I need to take away 3. Now I can cross off 1, 2, 3 0 pairs. There you go. So overall, what is my answer? How many x squareds do I have? Well, overall, I have 2x squareds. Then I have 5 7x's. And then 1 tiles, I have a total of 8. So that's my answer. 2x squared plus 7x plus 8. Now these 0 pairs are weird. They need you need them in order to correctly draw the subtraction. If it's not there, you need to add a 0 pair. Okay? What it does though, it's like adding the opposite. So we're going to be going to that very soon. It's like adding the opposite. But truthfully, the 0 pairs are the correct way to demonstrate this. So looking at this next one, same thing. Okay? We need to draw the very first polynomial. We have negative x's, we have negative 3x's. So there we have negative 3x's, so x squareds rather. And then we have 2 positive x's, and we have 3 1 tiles, which happen to be all negative. So we've got to shade them in. So now we're going to take away a negative x squared. Easy to do because it's there. I cross it off. Then we're going to take away negative 3x. But there's no negatives. Oh man, what do I do? Well, if it's not there, add a 0 pair. So there's 1 0 pair. I can take away a single negative. Add another 0 pair. I can take away 2 negatives. Add another 0 pair. And now, voila, I can take away my 3 negative x's. Same thing with the +4. Okay, so there's a 0 pair. I can take away a positive. Now another 0 pair. I can take away a positive. Another 0 pair. I can take away a positive. Whoops. So now that I have 4 0 pairs, I can take away the 4 positives that were not originally there. And the question is, what's my answer? I get negative 2x squared, that's what's left over, plus a total of 6x's, plus a total of negative 2, 4, 6, 7. So negative 7 1 tiles. Hey class, sorry, I just realized I made a mistake. Thanks to students for bringing it to my attention. Unfortunately, I drew an extra x, so I don't need this blue x right here because it's only 2 plus 2x. So that also changes our answer. When we collect like terms in, this should be a total of 2 plus 3, so a total of 5x. Okay, so please make note that I incorrectly drew how many x's. I drew an extra one, so that resulted in this answer being different. Okay, the PDF that's now posted will be correct. So our key mantra is this: if it's not there, comma, add a 0 pair. That is our mantra for doing our subtraction. If it's not there, add a 0 pair. If you keep that in your head when you're doing your subtraction, you got a chance. If it's not there, add a 0 pair. If it's not there, add a 0 pair. Okay? Now keep in mind that there's only going to be like a couple quiz questions. Quizzes are going to be, somewhat open book. And then on your test, there's 1 question or 2 questions on drawing, 1 adding, 1 subtracting. So it's not going to be a big deal. Okay? So these ones up above, we were supposed to do with algebra tiles, but I didn't have them. So now we're kind of practicing drawing some more. We're only going to do 2 more. Okay, so the number 1, draw the first polynomial. 2, subtract each piece from the second polynomial. 3, if the piece is not present to subtract, add a 0 pair first. Okay, so again, that's our mantra right here. If it's not there, add a 0 pair. So now we're going to have more room to draw because this is the drawing section. So what I encourage you to do is do the question and then watch the video. I got 5x squareds, all positives. I have negative 4x, shade them in. And then I got plus 3. And what I'm going to do then is I'm going to take away 2x squareds that are positive, 1, 2. I'm going to take away negative 3x's, 1, 2, 3. And I'm going to take away a plus 4. 1, 2, 3. Oh, it's not there. Add a 0 pair. And so now I can take away my fourth one. So what do I have overall now? I have 3x squared. I have negative x, so a single one. And I get a negative 1 tile. Notice here, you don't have to write the negative 1 coefficient, but you definitely have to write the negative 1 when it is going to be your constant. Okay, good. Again, try example number 5 first. You draw it, then watch the video. Highly recommended. Okay, so negative 3x, there's negative 1, negative 2, negative 3. Okay, here's my x's, 1, 2, 3, and here's my 1 tiles, which are negative 1, negative 2, negative 3. And so now I'm going to look to subtract. I'm going to take away a 2x squared that's positives. Well, there's no positives, so if it's not there, add a 0 pair. Oops, sorry. I'll shade this one in, and there we go. And I'm going to add 2 0 pairs. Why? Because there's 2 I got to take away. Now that it's there, I can remove the positive 2x squareds. Looking at negative x's, there are no negative x's. So if it's not there, add a 0 pair. There's a negative 1. Sorry, there's 0 pair, 2 0 pairs, and I need to draw 3 0 pairs so that I can take away negative 3x's. Okay, so I'm actually taking away negative 3x's. And the last one to take away is 2 positive 1 tiles. There are none, so if it's not there, add a 0 pair. And so now I have 2 that I can take away. Boom. What's left over? Negative 5x squared plus 6x minus 5 overall. Okay, perfect. There you go. Last question. You try it first and then watch the video. I'll just increase the size. So I have 4x squareds. Draw the first polynomial. Negative 3 1 tiles. Good. Now I'm going to take away a negative x squared. It's not there. Add a 0 pair. Now I can take away a negative. I'm going to take away a negative 3x. It's not there. Add a 0 pair. Good. And last one, 5. It's not there. Add a 0 pair. 3, 4, 5. Now I can take away my 5 positives. What have I got when it's done? I got 5x squareds. I got 4x's that are all positive. And I got 3, 5, altogether 8 1 tiles. I did not have my sign correct. So example number 6. On this example, I have written down that it's negative 8, which is correct. So originally I had positive 8, but that is not correct. So the correct answer should be negative 8 because all these tiles here are shaded in, and so it must be negative 8, not positive 8. Okay, that's those two corrections. Thanks for letting me know. So this is like you are good. And this is like you are adding the opposites. Some of you already noticed that. It is like you are adding a positive x squared, like you're adding a plus 3x, like you're adding a negative 5. So that's kind of what we use, okay, to go into symbolically with letters and numbers only and not drawing. But the drawings kind of help show that that makes sense. It's proof, okay? So here is our numbers and symbols. So what we have is we are actually subtracting all three pieces. We are actually subtracting a positive. Okay, welcome back. Sorry the interruption's a little weird because I have to break up the film. So we're going back to symbols. Looking here at this one. Keep in mind here, we are subtracting all pieces of this second polynomial. So this is a plus 3x squared, a minus 2x, and a plus 4. So we are, I'll use blue for the subtraction sign, we are taking away a positive 3x squared. And you can see there's a double sign resulting. We are taking away a negative 2x. And there's a double sign resulting. We are taking away a positive 4. And so a double sign is resulting. What happens then, when we drop our brackets, we have to correct our signs. So for the very first polynomial, nothing changes because there's nothing to correct. So we rewrite the first polynomial and everything stays the same. But for the second polynomial, we need to fix all this. So to fix it, you'll often hear teachers say, and previous teachers might have said this already, add the opposite. So when we fix our signs all change to the opposite sign that they were originally. So this plus 3x squared becomes a minus 3x squared when we combine our two signs. Okay. Here, when we combine our two signs, this negative 2x becomes a positive 2x because the double sign gets fixed. And this double sign gets corrected to the opposite of the plus 4 becomes a minus 4. And now you're able to collect all terms just like we did before, or adding the polynomials just like we did before. So 10x squared minus 3x squared becomes 7x squared. We have 7x plus 2x becomes 9x. And we have this here, a minus 5 and a minus 4 combined to give us a minus 9. So this question here, I'm showing you why this works, how it works. What's the reason behind adding the opposite? Okay. So that's the why. Now we're just going to practice adding the opposite. So what we're going to do is we're going to change this from a plus 3x squared. When we subtract it, it becomes a minus 3x squared. This minus 2x, when we subtract it, it becomes a plus 2x. And this plus 4, when we subtract it, it becomes a minus 4. So when you're rewriting this, the first step that you should do is drop your brackets and fix your signs. Okay, so this is what we call adding the opposite. So the next question I'm going to do, just fixing this section here, and I'm not going to show all these double sign stuff. So I'll show you what I mean here. So here for this question, I am going to fix my signs. I'll rewrite this one, nothing changes. And then I will change this to a plus 2x squared, change this to a minus 3x. Why? Because the subtraction tells me to add the opposite. And then the last one, this becomes a plus 4. And that's how you do correct subtraction. You need to add the opposite. So addition, no problem. But subtracting, you got to change the signs of the second polynomial. So 12 plus 2 is 14x squared. Negative 4x plus minus 3x becomes negative 7x. And this plus 6 and plus 4 becomes plus 10. Okay? So again, try question number 9. See if you can do it. I rewrite this one. Nothing happens. And now what I'm going to do is change all my signs. So from a plus 4, it becomes minus 4x squared. This becomes a plus 3x. And this becomes a plus 5. The change is occurring because in order to truly subtract the entire polynomial, I need to subtract all 3 terms. Okay. Once I've got my signs corrected, it's easy to do. Negative 7 minus 4 is negative 11x squared. 10x plus 3x is 13x. And plus 15 plus 5 is plus 20. So remember to add the opposite. All right, so when subtracting, correct your signs. Because it is like you're adding the opposite. And then you can't get it wrong. And the reason why is when we did the algebra tiles, you could see that if it wasn't there, you had to add the 0 pair. So that's another thing I'm just going to do. When you draw, keep in mind, if not there, add a 0 pair. So those are the two kind of key points for subtracting. One, when you're dealing with your symbols. So with our regular algebra, okay, so we're dealing with our algebra, shall add the word symbols. Okay, when subtracting, correct your signs. And when you're doing your drawing, if it's not there, add a 0 pair. So those are two key points for subtracting. Okay, so our last little bit of the video here, we need to just go and, I have no idea why that's there, but we're just going to go and do some applications. So just to review perimeter, perimeter is the area, sorry, the distance. Perimeter is the distance around an object. So for this triangle, basically what we're doing is we're going to add this side, and this side. So for perimeter, it equals side plus side plus side. So when we're looking at this shape here, it's going to be 4x minus 5 plus 4x minus 5 plus 6x plus 2. And everything needs to be in brackets because you're adding the individual pieces. The brackets show that this is a side length, this is a side length, and this is a side length. Now, if you're doing addition, yeah, it doesn't really make a big difference. You can't really screw it up. But it makes a big difference for subtraction. So our habits for addition will lead into proper subtraction. So then we can add them all up. 4x plus 4x is 8. 8 plus 6 is 14x. negative 5, and negative 5 is negative 10, plus 2 is negative 8. Okay, so we add all the sides for perimeter. Then, for this next one, now we're given the perimeter. The perimeter is 12x minus 10. So to find a side length, you will take your perimeter and you will subtract the side. And you will subtract the other side. Because when you take these two away, what's left over is going to be the unknown side. So let's start with 12x plus 10. And that's a whole entity, so you have to put it in brackets. And we're going to take away a side, 2x minus 3. And we want to take away the whole side, so you need to have brackets. And then you're going to take away the other side, 8x plus 4. And because it's the entire side, you got to have brackets. So then when you drop your brackets, this one doesn't change. But the subtraction applies to both parts, so we get minus 2x plus 3. Same thing over here. It applies to both parts of the side. We have to subtract both pieces of the side correctly, and so we get minus 8x plus 4. 12 minus 2 is 10. 10 minus 8 equals 2x. And then 10 plus 3 is 13 minus 4 is plus 9. And so that is the unknown side. This measurement, 2x plus 9, is the polynomial for that missing measurement, missing side. Last step in adding pyramid. So this one's pretty simple. These two are adding together, and this answer will go up above. So 3x plus 5x, 3x squared plus 5x squared is 8x squared, and then minus 3. Over here, we're going to add these two together, and then our answer goes right up above. So we get 2x squared plus 2. Now we have another question. So now these two, their answers get added together. Add your answers and you get 10x squared minus 1. And so that's the top of the pyramid. So you're adding these two together to get your answer, which goes right above. Subtracting pyramid, same thing, but again, it's going to be more challenging because you're subtracting. So what has to happen? Well, you have to change your signs. That's the tricky part. So your answer then becomes negative 2x squared minus 7. Again, you write your answer up above. Next question, you have these two that you're subtracting. So you got to change your signs, adding the opposite, and the answer goes up above. Negative 6x squared plus 4. So now you have your two answers right here, answer 1, answer 2, and you're going to subtract. Now in order to subtract correctly, you've got to have brackets around them, okay? So you got to have brackets. And then don't forget to change your signs, so this becomes positive x squared minus 4. So then your final answer will be positive 4x squared, and negative 7 minus 4 would be negative 11. Okay, and so this is going to be your answer right here on top. Any questions? Get a hold of me, message me, email me, let me know, and I'll go over it some more and help you.